In this video, we'll discuss isotopes and how to calculate atomic mass. Isotopes are atoms of the same element with different numbers of neutrons. All three of these isotopes have one proton, which makes them hydrogen, but they have different number of neutrons, which gives them a different mass. The mass number of each is based off of the number of particles in the nucleus. One particle, two particles, three particles. We call that the mass number. So since the mass number is 1 for this first isotope, we call it hydrogen 1. And the second isotope, the mass number is 2, so we call that hydrogen 2. And then the third has a mass number of 3, so we call that hydrogen 3. Again, the isotope name is written for the name of the element and then followed by the mass number. The mass number, again, is the number of protons and neutrons added together. We can use the isotope notation to describe individual isotopes. So when you take carbon and you look at the periodic table tile, we have the atomic number, we have the symbol, and we have the atomic mass, which is different than the mass number. Remember, the mass number is protons and neutrons added together. But since we have different isotopes that have different mass numbers, when we look at the periodic table, we use the atomic mass to describe the weighted average of all of those. So some things to note. The mass number and atomic mass are different. The mass number is protons and neutrons added together, and the atomic mass is the weighted average of all the isotopes of that element. And this is how you calculate the atomic mass. You take the percent abundance and multiply it by the mass number. And you do that for each isotope, and then you add that together for all the isotopes. In this example, boron has only 2 isotopes. So we take the mass times the abundance. The mass is 10.013. The abundance is 19.8. Notice this is a decimal. That's a percentage. We just have to convert from a percentage to a decimal. All you do is you move the decimal place over twice to the left. You do the same thing for both isotopes. So boron 11 has a mass of 11.009 and an abundance of 80.2%. Again, we move the decimal to the left twice to get 0.802. Multiply that by the mass. And so you have, for boron 10, 1.98, and then boron 11 is 8.83. Add those together and you have an atomic mass of 10.81.